All right, calculus class, we are shifting the focus of the course. Right now we're going from integration techniques and ways to come up with areas under the curves to sequences and what we call series. Sequences are kind of like a set of numbers, and there's typically a pattern to the numbers that are in that set. And then a series just means we're going to add those numbers together. So when we're dealing with a sequence, just think of it as like a list of numbers, and there's some kind of a pattern to the next number. So this is just so you can see if I plugged in 1 for n, I'd have 2 times 1. It's kind of like a function, right? Where instead of x is the variable, n is the variable. So 2 times 1 is 2, minus 1 is 1, and then 1 squared is 1 plus 2 is 3. And then if I had the second number that's in the sequence, I'd have 2 times 2 minus 1. And then 2 squared plus 2. 4 minus 1 is 3. 4 plus 2 is 6, and then 3 6, I can reduce that to 1/2. And then if I'm going to find the third number in the sequence, which is what it says, I would just plug a 3 in there for n. So 2 times 3 is 6. 6 minus 1 is 5. 3 squared is 9. 9 plus 2 is 11. So there's an example of a sequence, and there's the first 3 terms of the sequence. We're just plugging in. It kind of, you can think of it like that, right? Like if you remember function notation, right? And you replace n with 1, 2, and 3. It's really no different than that. The only real difference is like we typically write these as sets. So it would be like 1/3, 1/2, 5/11ths, and then dot dot dot, because there's no upper bound on n given to us here. So you can think of a list. You can also call it like a set of numbers with a pattern.